Hey guys, so we're going over resistance in fluid systems in this video. I want you to get out a piece of pen and paper or take notes on the side, save this video, whatever you can do, and remember you come back to it if you need any help with anything. I'm going to go through and explain everything as best I can. These are your notes. You're going to take a quiz after this later. This is resistance in fluid systems. Get ready to go. Here we go. Next one. So we're looking at drag first. So we got two kinds of drag examples here. We got a space shuttle and a funny car in drag racing. So which one's the right kind of drag? Well, they both kind of can give us examples of drag in this way. So when a solid object moves through a fluid, there's a force called drag that opposes the motion. Now both of these examples give us fluid as air. Air is considered a fluid. Fluids also water, oil, gasoline, all those different things are fluids as well. Just remember that air is also a fluid because it has to be relative movement. So if you're just sitting still like that, then there's no drag. But if I'm moving side to side, then I've got drag because I'm getting a little bit of that resistance to movement in the fluid. So what's happening in the space shuttle? Its drag is slowing it down. But what's happening with the funny car? It's overcoming drag to go faster. That's why it's very streamlined. It's got the fins to give itself push down, no lift. It wants to just go, go, go and not lift up and off. It also has really slick tires in the back because it doesn't want to have a lot of drag from those tires. It wants to be able to get its grip and get moving and not worry about anything extra grip like we have in our regular cars. Moving on, laminar or streamlined and turbulent flow. So laminar is streamlined, turbulent is different. So drag depends on many factors: speed of the object or fluid, size and shape of the fluid, physical properties of the fluid. So those are the three main things. So if it's moving very fast, it's going to have more drag just because it has so much contact happening quickly. It's a really large object or very flat. So if you're a very flat object, it's not going to go, it's going to create more drag. So that's why a boat or an airplane is very cylindrically shaped because it has more streamlined or aerodynamic properties to it. Physical properties of fluid: is it viscous? Is it dense? Different things like that. Drag is difficult to calculate. Why is that? Because we don't really have a way of measuring what it is. We just have to kind of estimate what that is. Flow can be laminar or streamlined flow. So streamlined is a slow, smooth flow over a surface in which the paths of the individual particles do not cross. So they're not actually rubbing on each other, so there's not a lot of friction between the particles within the fluid. Fluid speed at surface is zero, and fluid moves in theoretical layers or laminates with increasing speed away from the surface. So higher up surface, it's actually moving faster as it gets away from it. So at the surface, it looks like it's not even moving, but on the inside, it's moving faster and faster. Drag is produced by the friction between layers of the fluid, known as frictional drag. Turbulent flow is an irregular flow with eddies and whirls. See in the picture here, you got a river. It's very turbulent because it's not moving very quickly. You look back at the other one, you see those lines over the fountain are actually shooting very unturbulent water. It's very direct shots. There's not a lot of turbulence. You can see the little bumps in there because there's a little bit of vibration, but it's not very turbulent. It's very straight. You can see clear. It's very clear looking. So less turbulence is going to be more clear. Becomes more turbulent and has more irregular flow. It's going to become more of that washy looking, where you got all that soapy kind of sudsy looking because it's actually stirring up and creating air pockets in there. Turbulence is produced by high speeds, non-streamlined shapes, and sharp bends in the path of a fluid. So think about a swimmer in the pool. If they swim faster and faster, you see more big whirls and eddies because they're moving so fast, they're causing that water to move and be very turbulent. That's how they get moving faster. And then if you're in a river tubing or ever go to the water park like Schlitterbahn, you're actually going to get yourself caught in eddies and whirls sometimes because there's objects in there that cause the water to start to spin and be more turbulent instead of a good constant flow. Then let's see, we have relative velocity. It says the pressure difference causes a force to act on the object in the direction opposite to its relative velocity. So if you have a pressure difference, the force is going to act opposite. So if you're moving left, it's going to go right. Force is called pressure drag. Quiz time. So take a minute, pause the video, answer the questions, and then come back to get the answers. Good luck. All right, here's the answer key. So the first question was, drag in a fluid depends on three things. These things are Speed of the object or fluid, size and state of the object, and physical properties of the fluid. The other question was, irregular flow of a fluid with eddies and whirls is called a blank. Turbulent flow. Called turbulent flow. All right, here we go. Viscosity. We got 3 fluids on the right. Very different fluids. All kind of things you could eat, though. 2 of them are very sweet. 1 of them is just plain tea. You could make it sweet if you did a different way. But let's just call it hot tea that's herbal. That's it. Because that's what you kind of have looking there as a teapot with herbal tea. So resistance inside of a fluid due to the electrical forces between atoms and molecules in a fluid is called viscosity. We've talked about the viscosity a little bit before, and that is a big deal. Viscosity is different. So which of those 3 fluids is the most viscous? Well, the honey is going to be the most viscous because it's actually the most resistant to flow. So those molecules are actually causing more friction between each other, so it takes longer for things to flow. Chocolate syrup is hot, so it's very thick when you start, but it's hot now, so it actually flows really easily because it's become hotter, so it's become less viscous. The hot tea is actually less viscous than the honey, but not as more viscous than the chocolate syrup because it's most like it has a different friction between the particles. So we got those 3 things there. Higher viscosity, greater fluid's resistance. Honey has higher viscosity than water. Viscosity of most liquid decreases as the temperature increases. So if you heat up your honey before you put it on your waffles or you put it in whatever, you're actually going to have an easier time pouring because it's going to be hot. So the viscosity of most gases increases with temperature. So as you heat up a gas, say oxygen, you're actually going to become more viscous. It's going to be harder for it to flow. It's going to become more sticky. Next slide. Stokes Law. So the Stokes Law just really tells you that it's got things have a terminal speed whenever you're flowing through a fluid. So in this case for skydiving, there's a terminal speed you reach. As you're going down, it's only going to get you so far. You only go so fast as you're flying down before you have to pull your parachute to, but there's a certain speed you'll actually reach. You have to get so high that you can actually have enough time that as you fall down, gravity can pull you enough to overcome drag force of your body in the air to overcome that force the friction force fast enough that you'll hit terminal velocity at a certain point. Typically, you don't jump from that high. Sometimes you do. And then you hit that terminal velocity. You can go that way for a little while. You won't speed up or slow down. You actually keep a constant speed the whole time based on how much drag you are. That's why if you ever played Call of Duty or something like that, or you ever watched some like Mission Impossible where they have wingsuits, they put their wings out and fly a little bit. They're actually using this property to give themselves more speed or less speed. So you open up the wings, you go slower, cause more drag. You close them down, you go faster. So Poisson's law, I'm not sure exactly how to say it. That's okay. Just PLL law. Gives a volume flow rate of a fluid flowing through a tube or pipe. In this case, the pipes I chose, or tubes, are the heart and blood vessels. So you're actually going to have the idea that fluid layer at the center moves the fastest and the layer nearest to the wall moves slowly. So in this case, this is why we get plaque buildup in our blood vessels, because the plaque builds up around the outer edges of the walls of the lining of the blood vessels and arteries and vessels. So that plaque builds up because the fluid is actually not moving as fast on the outside versus the inside. So actually you can stick to the walls a little better. That's why if you have a good fluid movement, you have that constant flow. So the better you are pumping and more pressure, you're going to keep that fluid moving at a more closely related speed. If you have a really big pipe, you're going to have fluid stick really far outside. I'm not saying it's not moving at all. It's going to keep moving a little bit no matter what. But it likes to flow through the middle because it's relating to itself instead of touching to the pipe walls. All right, factors affecting flow through a pipe. Resistance decreases the flow rate of a fluid through a pipe. Obviously, we've been talking about that. Poisson's law shows this how this resistance depends on 3 factors: radius of the pipe, length of the pipe, viscosity of the fluid. So the smaller the radius, longer the pipe, or more viscous the fluid, the more resistance to flow in the pipe. So I got 2 pictures here this time. This is kind of drawing from my background. The one at the bottom is what I used to do. I actually used to run and help do these oil rigs here. So that's an oil derrick. It actually is a pumping unit that gets oil out of the ground on terrestrial or land-based oil wells. This would be a vertical well. This is a pretty large one in this case from looking at the size of it. And what it does is actually uses pressure differences and has pipes in there and rods to actually cause fluid flow by pumping up and down, if you remember that. Now that pipe, how does it compare to what I see in the other picture? That's an oil rig in the ocean, right? So that's a platform in the ocean. But what's the difference in the size of pipe? You'd be surprised. It's quite a bit different. Well, which one's bigger? Well, if you don't know, the one in the ocean's bigger. They've got really fat pipe. They got really, really wide pipes. You know, on the oil well on land, they're only about 2 1/4 or 2 3/4 to 2 7/8 of an inch. So they're not very big. I mean, if you really think about it, this can I have right here, how big is that? Not that big. But it goes anywhere from like 2 1/4 inches, you know, something like this, to up to like 4 inches in diameter, which is getting pretty big, but it's really not that much, not big compared to what I can't even show you the size of the hole on those oil rigs in the ocean. So why is that? Well, they got a lot more oil coming up and a lot more pressure from the underground. So they put them right on top of a spot where they need the oil. In both cases, they find oil in the ground or below surface level, drill down into the oil where the oil's at. And on land in Texas, it's called shale. So they drill into the shale zone that has the amount of oil they want, and then cause low pressure zones by drilling down and opening a hole up and have it come up to the surface. Same case here with the platform. They just use a bigger pipe and have larger radius. Length of the pipe in both cases, you want to have things close to where you get them. So that's why they are typically closer to land, or they have to send ships out to bring the oil over, because they send a ship out to the sea deck and then move it to off the rig onto the ship and then take it to land. In the other case, the wells are typically pretty close to where you actually store the oil. Sometimes it's on the same location even, because it takes so much effort to move it. You don't want to have it really far away because it costs more to move it. All right, one more quiz here. Pause it, answer the questions again. Get the answers after this. All right, so temperature, terminal, radius of the pipe, length of the pipe, viscosity of the fluid. Let's look at them again. I'll bring a little crane back in here. Viscosity of liquid decreases when the blank increases. Well, that's what? Looked at it. Temperature, because it's a liquid, not a gas, liquid. The blank speed of a falling object is the constant speed that occurs when the drag force equals the gravitational force. Terminal, right? Radius of the pipe, length of the pipe, viscosity of fluid. What are those? 3 factors that affect fluid resistance in a pipe. All right, so after this, go take your quiz. Good luck. Do your best on that. Have fun. See you guys next time.